Here is the main dimensions. Design of main dimension. Width of one limb, width over two limbs, width over one limb and width over two limbs. You can see in figure. Here is SW, means height of window. Following are the nomenclatures for overall core dimensions can be found out once core and yoke design is complete. Following nomenclature is used in all over dimensions. See here, A is width of A is equal to width of largest stamping. D is equal to diameter of circumscribing circle. D is equal to capital D is equal to distance between centers of adjacent limbs. SW is equal to height of window. WW is equal to width of window. HY is equal to height of yoke. H is equal to overall height of transformer core. W is equal to overall width of transformer core. Width over three limbs. Nomenclatures are same. For single phase transformer, D is equal to D plus WW. dy is equal to A. dy is equal to A. H is equal to SW plus 2HY. W is equal to D plus A. Also we can write width over one limb is equal to outer diameter of high voltage winding. Width over two limbs is equal to D plus outer diameter of high voltage winding. For single phase W is equal to D plus A. For three phase W is equal to 2D plus A. What is main difference between single phase and three phase transformer is in single phase transformer two limbs and two yokes. In three phase three limbs plus two yokes. Now design of HV and LV windings. Design of winding involves finding number of turns and area of cross section. Various steps in designing of winding. The number of turns in the winding is found out using EMF per turn. Number of turns per phase. It is LV winding is equal to phase voltage of LV winding upon EMF per turn. TLV is equal to VLV by ET. ET is EMF per turn. You know the relation of ET. ET is equal to K under root of Q. The number of turns found out using above formula may be fractional and it should be rounded to nearest higher integer. For example, 13.6 is equal to 14. Then find phase current voltage on LV side. Formula is given. After for three phase and single phase, formula is given. The number of turns you have to find by using above formula. It may be fractional. We can convert into main value which we required. After this, cross-sectional area of LV conductor is found out by ALV is equal to ILV by delta LV into mm square. ILV upon delta LV into mm square. Delta Ly is current density in ampere per mm square. The suitable value is selected from the range as per transformer capacity. Once area of conductor is found out, then dimension of conductor are generally selected. After referring standard IS tables of copper conductors, generally rectangular conductor are used for LV windings. When the cross-sectional area of LV conductor exceeds 50 mm square, then instead of single conductor, multiple conductors in parallel called as standard conductors are used. Sometimes selected conductor dimensions may give slightly higher area. Then in this case, current density is recalculated as per the new area.